Yeah, hello to you. Your favorite mathematics teacher. That is Sir Lawrence from St. Mary's School. That is Koforidua, to be precise. I'm going to take you through one or two steps in solving two set problem. How to solve two set problem. Okay, this is going to be brief and very short. Before we start the lesson, let us try to warm ourselves up. Let us try to refresh the mind. Let us try to refresh the mind because there's a saying that all work and no play makes Jack a dull boy. You understand that? So let us try to refresh our mind on one or two. Let's refresh our mind. Let us try to calm the nerves down and let's start the lesson. Before that, let's take this. Let's take this and then we calm our nerves down. Let's take this. This is to calm your nerves down. Oh. Blessings on my God. That's why I say my God. I say my God. Too many confusion, too many distraction. I say my God. You see this one is driving so many people crazy, Yeah. Oh. All right, it's okay, it's okay, it's okay. Okay, let's start. Let's get the lesson rolling. All right. A quick one, okay, how to solve two set problem. How to solve two set problem. Now, before you can be able to solve two set problem, right? That is word problems concerning two intersecting sets, okay? We use what we call the Venn's diagram, okay? With the Venn's diagram. So before you can be able to solve a two set problem, you need to understand the various regions of the Venn's diagram. A quick one over that, a quick one. I have my various regions. Let me name my regions. Region 1, region 2, region 3. Fish, don't distract my class. If you walk back and forth, I'll shoot at you. Okay, let's go. Okay, that's my region 4, right? Now you need to understand the various regions of the Venn's diagram, okay? Now, my region 1, okay, my region 1 is representing, right, the number of elements in A only, okay? My region 1 represents the number of elements in A only. That is A intersection B complement, okay? That is A intersection B complement. Good. So my region 1 is representing the number of elements, okay, in A only. The number of elements in A only. That will be my region what? My region 1. Take note of that. The number of elements in A only. So this region, okay, that's my region 1. It's representing the number of elements in A only. Good. That is A intersection B complement. That's what I'm having here. A intersection B complement. Number of elements in A only. Good. Now, my region 2, okay, my region 2 is representing number of elements in both A and B. My region 2 is representing the number of elements in both A and B. That's my region 2. That's my region 2, right? So my region 2 will be the number of elements in both A and B. So that is A intersection B. A intersection B. A intersection B. That's the number of elements in both A and B. That's A intersection B. That's my region 2. Now my region 3 precise automatically will represent the number of elements in B only. The number of elements in B only. The number of elements in B only. That is A complement intersection B. A complement intersection B. A complement intersection B. That is my region 3. Okay, that's my region 3. The number of elements in B what only. Number of elements in B only. That is A complement intersection B. A complement intersection B. Now my region 4, right, is representing those who are neither in A nor B. Okay, the elements that are neither in A nor B. Right. That is that will give you. Let me choose my colors. Good. So the whole of this region is representing region 4. All of this place is representing region 4, right? That is, they are outside the circles, okay, but they are in the rectangle. They are part of the universal set, but they are neither in A nor B. When you mention the members of A, they are not part. When you mention the members of B, they are not part, but they are part of the universal set. They are part of the rectangle, right? They are inside the rectangle, okay? So those people who represent, that is A union B or complement. Those people will represent A union B or complement. A union B or complement, okay? My region 4 will give you A union B or complement. Let me put it in a better way for you guys. Good. So my region 1, okay, that is my region 1 is giving you A intersection B complement. My region 2 is giving you A intersection B. My region 3 is giving you A complement intersection B complement. That is members in A. Okay, sorry. Members in B only. Members in B only. Members in B only. Right. Good. And then my region 4 will give me A union B or complement. That will be my region 4. A union B or complement, meaning that they are part of the universal set, but they are neither in A nor B, okay? They do not belong to any of the two sets, A and B. Do you understand what I'm saying? Good. So these are the various regions of the Venn diagram. When you get the understanding like this, it will boost up your morale, to boost up your, your ability to be able to solve questions on two sets of problem. Right. So these are the various regions of the Venn diagram that's concerning two intersecting sets. Without wasting much time, we're going to take the first example without wasting much time. Let's take our first example. I'm going to type the question. So please, let's move on. Now, in a class, so in an examination, for a class of 100 students, in an examination for a class of 100 students, 73 passed mathematics mathematics, and 80 passed English language. And 80 passed English language. Good. Now, if each student has in at least one of the subjects, So we have A, use a Venn diagram to illustrate. Use a Venn diagram. Use a Venn diagram to illustrate the information. To illustrate the information. And then B, find the number of students who passed in both mathematics and English language. Good. So that's my question, right? In an examination for a class of 100 students, 73 pass mathematics and 80 pass English language. If each student passed in at least one of the subjects, so meaning that none of the students failed. That's the meaning of that statement, okay? None of the students failed, right? So if each student passed in at least one of the subjects, so none of them failed any of the subjects, nobody failed any of the subject, right? So if the person didn't pass in mathematics, the person will pass in English or English language, okay? Take note of that. And we are supposed to represent this information on a Venn diagram, okay? So that is our Venn diagram. But before we represent the information on a Venn diagram, let us try to write down or to put down the important facts that we need to represent on a Venn diagram, okay? We need to bring out the important facts in the question that will help us to put out a correct Venn diagram. That's what we're supposed to look at. And we're going to get all the information we need, okay, from the question given or from the problem given. Good. Now let us look at that. I'm cleaning my Venn diagram here. Good. So in an examination for 100 students, okay, meaning the number of students who took part in the exams, that is 100, right? So number of you is equal to 100. Okay, we have 100 students. And then 73 passed mathematics. So number of students who passed in mathematics, that's 73. Okay, so mathematics, number of students who passed in mathematics, that is 73, okay? And 80 pass English language. So the number of students who pass in English. So English language, that is 80, right? Now, it said if each student pass in at least one of the subjects, okay, so meaning that we are not going to have region 4 because each student pass in at least one of the subjects. So none of the students fail, okay? None of them fail, so we are not going to have region 4. Take note of that. Now, but we don't know the number of students who pass in both subjects. We're going to represent the number of students who pass in both subjects with a variable, okay? We are going to represent the number of students who pass in both subjects with a variable. So we can say let X be number of students who pass in both subjects. Right. So let us represent the number of students who pass in both subjects. So this is the information we're going to represent on a Venn diagram. Okay. So we draw a Venn diagram. A rectangle with two intersecting circles. Okay. A rectangle with two intersecting circles. So number of U, that'll give you 100. So the whole rectangle is representing the number of students who took part in the examination. Okay. The number of E, those who pass in English language, that's 73. Okay. The number of students who pass in mathematics, other round is 73, in English is 80. Sorry, let me do that question for you quickly. So those who pass in English language, that is 80. Good. Now, we are going to represent the intersection, okay, with a variable that is X, which we have named already. Good. So X. Right. Now, we need the number of students who pass in English only. Okay. When you subtract the intersection, this is the intersection. That's the intersection. Right. Good. So when you subtract the number of students, okay, who pass in both subjects, right, from the number of students who pass in English, you're going to obtain the number of students who pass in English only. Okay. So you want the number of students who pass in English only. And that would be 80 minus X. And the number of students who pass in mathematics only, that when you subtract the intersection, that's the number of students who pass in both subjects from the number of students who pass in mathematics, okay? So the number of students who pass in mathematics only, that would be 73 minus X. Now, we don't have any students who did not pass in any of the subjects. Well, the question says that if each student pass in at least one of the subjects, okay, so none of the students failed in any of the subjects, so there wouldn't be any region 4. That was the complement. Good. Now, this is a universal set. The whole rectangle is representing the universal set. Take note that when you add all the various regions, okay, when you add all the various regions in a Venn diagram, you should get the universal set. When you add all the various regions, okay, you should get the universal set. Meaning that when we add, that is my region 1 and my region 2, my region 3, and my region 4, right? We should get number of U. Okay, we should get a number of what? Number of U. So region 1, those who pass in English only. Region 2, those who pass in both English and mathematics. Region 3, those who pass in mathematics only. And then region 4, okay, those who do not pass in any of the 2 subjects, which we don't have, that is 0 for now in this question. Good. So we need to write an equation connecting the variable. So we're going to have my region 1 plus margin 2 plus margin 3 plus margin 4. That should give me a number of U. So margin 1, that is 80 minus X, plus margin 2, that is X, plus margin 3, that is 73 minus X, plus margin 4, that is 0. Okay, because each student passed in at least one of the two subjects. So meaning region 4 is 0. We don't bring it, it's 0, so don't write anything. Should be equal to 6, that is 100, sorry. That is 100, okay? The number of students who took part in the examination, that is 100. Good. We're going to solve for X. Now we have negative X here. Okay, we have negative X plus X. Will cancel out. Negative X plus X will cancel out. That will give you 0. Now we add 80 to 73, sorry. We add 80 to 73. That will give us 153. 80 plus 73, that is 153 minus X equal to 100. Okay, so meaning 153 minus 100, grouping of like terms, should be equal to X. Now, 153 minus 100, that'll give us 53. So X is equal to 53. X is equal to 53. So meaning that 53 students or 53 candidates, okay, pass in both mathematics and science. 53 candidates pass in both mathematics and what? In science. 53 candidates pass in both mathematics and science, right? Now, they can ask a lot of questions. They can ask a lot of questions concerning this. They can ask a lot of questions, okay? They can ask you to find the number of students who pass in English only. Find the number of students who pass in English only. They can ask you to do that, to find the number of students who pass in English only. Now, when we subtract the intersection from the number of students who pass in English, 80 students pass in English, okay? And the number of students who pass in both subjects, that is 53. So when we subtract 53 from 80, right? When we subtract 53 from 80, that will give us the number of students who pass in English only. So that is 80 minus 53, and that will give us 27. That is 27. So the number of students who pass in English only should give us 27. That is 80 minus 53, right? 80 minus 53, that gives us 27. And then the number of students who pass in mathematics only, they can also find the number of students who pass in mathematics only, right? So the number of students who pass in mathematics only, that is when you subtract the intersection from those who pass in mathematics, that is 73 minus 50. 73 minus 50, that gives you 23. So that is 23. Good. So 23 students pass in mathematics only. Now you can be asked to find the number of students who pass, okay, who pass in only one subject or exactly one subject. The number of students who pass in only one subject or exactly one subject. When you are being asked that question, meaning you are supposed to add the number of students, okay, you are supposed to add the number of students who pass in English only to the number of students who pass in mathematics only, okay? So exactly one subject, or only one subject, right? Exactly one subject or only one subject will be those who pass in English only, that is 27, plus those who pass in mathematics only, that is 23. So, okay, these are some of the questions that they can ask. They can also ask you to find the number of students who pass in one or two. Listen to the key words, one or two. Students are always confused with this words, okay? One or two, one or two, one or two, one or two. Find the number of students who pass in one or two, one or two. So meaning that we're going to add the number of students who pass in English only, plus the number of students who pass in both subjects, plus the number of students who pass in mathematics only. That is one or two. English in your mathematics, one or two, one or two. So that should be 27 plus the intersection, that is 53, plus those who pass mathematics only, that is what, 23. Okay, so when you hear those words, when you see those words, 1 or 2, meaning you should add region 1 plus region 2 plus region 3. That should give you 1 or 2. Okay, region 1 plus region 2 plus region 3. Clear. But if you are being asked to find the number of students who pass in exactly one, or only one, exactly one or only one, that will be my region 1 plus region 3. Region 1 plus region 3. Good. Now let's take another example. Let's take another example. I'm going to clear this, guys. So pardon me. So let's take another example, right? In a class of 38, well, let me type this one too. Okay. In a class of 38 students, 18 can play table. 80 can play table tennis, right? 80 can play table tennis. 20 can play hockey. 20 can play hockey ball, right? While 9 can play both games. So A, use a Venn diagram. Use a Venn diagram to illustrate this information. And then B, how many cannot play any of the games? How many cannot play any of the games? And precisely should be a question mark. Good. So that's the question. In a class of 38 students, 18 can play table tennis, right? 20 can play hockey ball, while 9 can play both games. Use a Venn diagram to illustrate this information. How many cannot play any of the games? Good. Again, we need to put down the important facts we're going to represent on the Venn diagram. So now, in a class of 38, okay, in a class of 38, so number of you is equal to 38, right? 18 can play table tennis. So tennis. That is 18. And then 20 can play hockey. So hockey, 20. 9 can play both games. That is hockey, intersection, table tennis. Okay, so the intersection. This time we have been giving the intersection. I love this question. We have been giving the intersection. Okay, so table tennis, intersection hockey. That is 9. Good. And we have been asked how many cannot play any of the games. Okay, how many cannot play any of the games? Those people who are in region 4, they are part of the whole rectangle. Okay, but they can neither play table tennis nor hockey. They cannot play any of the games. They are part of the class. They are, let's say, they are in a school. The whole school is representing the universal set. They are in a school. Okay, they are in a school. When we mention or when you call players of table tennis, they are not part. Those who can play hockey, they are not part, but they are part of the school. Okay, we need to solve for those people. They are asking us to find those people. Right, good. So we're going to represent those who cannot play any of the 2 games or any of the games with a variable. Okay, so let X or let Q, let me this, I'm using Q. Let Q be the number of students who cannot play both games, right? Let Q be the number who cannot play both games. So we're going to present this on a Venn diagram. When I'm teaching like this and these people are trying to interrupt my lessons with this Oprah thing, is it by force to update Oprah? I'm not interested. Good. So we have number of U, right? That is 38, the whole rectangle. Okay. And then table tennis. Number of T. That is 18. Let me do it well. So that to be visible. Let me do it so let me do my circles well so that to be visible. Good. And then number of H. That will be 20. And then the intersection is 9. Okay. And then let's Q be the number who cannot play both games. So Q will be here. Q will be here, right? Q will be there. Good. Now, let's move on. Number of students who play table tennis only, okay? Number of students who play table tennis only. And when you subtract the intersection from 18, that gives us the number of students who play table tennis only. That is 9. That is 9, okay? When we subtract the intersection, right? When we subtract the intersection from those who play table tennis, that is 18, that'll give us 9. Those who play table tennis only. We need those who play hockey only. Again, we subtract 9 from 20. We subtract 9 from 20. That'll give us 11. Okay, that'll give us 11. That is those who play hockey ball only. Remember that there's my region 1, margin 2, margin 3, margin 4. Okay, if I add region 1 plus margin 2 plus margin 3 plus margin 4, that should give me number of U, right? So margin 1, that is 9, plus margin 2, that is 9, plus margin 3, that is 11, plus margin 4, that is Q, is equal to 38. That should give you 38, right? So let us add 9 plus 9, that'll give you 18, right? Then 18 plus 11, that is 29. So 29 plus Q equal to 38. Then Q should give us 38 minus 29. And that should give us 38 minus 29, that gives us 9. 9. That should be 9, right? That should give us 9. Let me write it. Wow. One more space. That should be 9. So Q should give us 9. So meaning that 9 students cannot play any of the 2 games. 9 students cannot play any of the 2 games. 9 students cannot play any of the 2 games. Well, ladies and gentlemen, it's been a nice ride. It's been a nice ride, and I believe you enjoyed the lesson. You have enjoyed the lesson to the fullest, okay? And I believe from today, after watching this video, anytime that you are giving questions concerning 2 intersecting set, that is 2 set problems, you will be able to do justice to it. You should be able to solve it. Now, to be good in mathematics, you need to keep on practicing a lot of questions, okay? You need to keep on practicing a lot of questions. That will make you perfect. They say practice makes a man what? Perfect. So you need to practice more to become what? Perfect. On this note, we end today's lesson here. But you know, I'm not going to leave it just like that. Let me just close the lesson, you know, in a nice way. Let me close the lesson. You know, there's this trap, you know, trying to say something like Benzema. Let's just fool Benzema small. Okay, let's just fool Benzema small. Oh, yeah, I don't like that too. I want them to fill the Benzema. Okay, I want them to fill the Benzema small. Let's go. Yeah, let's go. Oh, DJ, you don't want me to end my lesson today. The DJ don't want me to end the lesson today. Don't mind the DJ. We're on course. We are still on course. Yeah, the DJ. Okay. This is mathematics is simple for you, right? You learn mathematics with fun, you know, with enjoyment. Maths is entertaining. It's an entertaining subject, you know, very entertaining subject. It's not difficult at all. It's all about principles. You just follow the principles, you get there. All right. So don't let anybody deceive you that mathematics is difficult. It's a lie. Okay, it's a lie. Just follow the principles given to you, and you get there. Oh, go. Yeah. You have to learn myself. The mass is sweet. Bye bye.